Okay, the other option to expand a binomial. So this, I just expanded it already just so I can show you the other way to do it. So it makes it easier to kind of set it up. So this guy right here has a to the power of 6. You, of course, could use your Pascal's triangle to expand it out, and that's probably the way you're going to do it for your homework problems. But if the other option is doing something called using combinatorics, which sounds really fun anyway and pretty cool. But what it would do is you would know how to find all of your A's and your B's. So that part would be the same. Combinatorics allows you to get the coefficients just like Pascal's triangle. The notation for combinatorics, are you ready? It's going to be N choose R. This notation right here that you are going to use is actually something that has factorials in it. And if you don't know what that means, this formula for this notation is n factorial divided by r factorial times n minus r factorial. Wait a minute, Miss Blake, what the heck is this? This n factorial, is this n? No, it's not n, super excited. So if you had 5 factorial, that's not 5, right? This guy right here would be 5 times 4 times 3 times 2 times 1. So a factorial is whatever that value is, you multiply it by every descending value all the way until you get to 1. So that is super, super cool, super interesting. If you didn't know all that already, that's actually, you can find this on your math button on your calculator. If they ask for these numbers without a calculator, which they don't expect you to do combinatorics, but this is a cool time to kind of talk about it because it's a way to be able to find a term in something that has a really large degree. So this guy right here, if I wanted the coefficient of this one right here, the notation would be 6. The n is always whatever the degree on the binomial is. So this would be 6. C is for choose, and then your first term always has a 0 here. That 0 has to kind of connect with the idea of you have to do first term is going to give you a power of 0 for that coefficient. This is going to be your second term. This is going to be your third term. This is going to be your fourth term. This is going to be your fifth term. This is going to be your sixth term. And that's going to be your seventh term. So what I wanted to point out is whatever the degree is, which I already said this in the last video, but whatever your degree is, there's always one more term than what the degree is. So if they were to ask you for the sixth term, what I want you guys to notice is whatever term number it is, so your term number is actually going to be connected with whatever your degree on your B value is. But we'll talk about that in a minute. Okay, so notation for this is 6 choose 0. This guy right here is going to give you a value of 1. If you plug that into your calculator, which you can get by going to math, probability, and then it's N choose R, NCR and NPR. I'll talk about the difference between those later. We're doing choose because order doesn't matter. This one right here, right? So I'm going to erase this little formula right here, which we'll talk about later. This guy right here is going to be 6 choose 0. This is 6 choose 1. This is 6 choose 2. This is 6 choose 3. This is 6 choose 4. This is 6 choose 5. And this is 6 choose 6. So that guy right there is what that, how you can get those really quickly on your calculator. You can literally go to your calculator and then you put the 6 in the little space and the 2 and the value of 15 will come up. Now, how would you get that without a calculator? Using the formula, this would be 6 factorial divided by 2 factorial times 6 minus 2 factorial. So this guy right here could be 6 times 5 times 4. Now what's cool about factorials is you can stop anywhere you want. So if I have 5 factorial, I can write that as 5 times 4 times 3 factorial. I can stop wherever I want, and I'm going to be really smart with this because I see that this in the denominator is going to be 4 factorial, and so you can actually divide those. And then 2 factorial is just 2 times 1. So I can divide 2 times 1 by 6, leaving a 3, and 3 times 5 is 15, right? But I'm not going to make you guys find these answers without a calculator. What I'll have is just this number set up, but you don't actually have to find the value. So just FYI. Okay, the other way that they write this notation is actually with a parenthesis, and it's going to say whatever the n value is going to be the first number in this top parenthesis, and then right below it is going to be whatever the r value is. So this is 6, choose 1. This is 6, choose 2. This is 6, choose 3. This is 6, choose 4. This is 6, choose 5. And this is 6, choose 6. So that's the other notation, and that's the notation I'm going to do the next problem that I'm going to show you guys. So this guy right here, 6, choose 0, you plug this into your calculator, you're going to get 1. 6, choose 1 is 6. Now, what does this actually mean? What it means is if you were to have like 6 books, they're asking you how many different ways, it's a counting notation. How many different ways could you choose 1 out of the 6 books? So you'd be like, well, I could choose the first one, the third one, the fifth one, this, right? You could choose 1 of any of those 6. This is asking how many different ways could you choose 2 of the 6. I could choose the first and the second, the first and the third, the second and the fourth, the fifth and the sixth, the fifth and the second. You get the idea, right? So all of those added together are going to count up to 15, and order doesn't matter, right? So the fifth and the second would count the same as the second and the fifth. And PR, those would count differently, just so you know. Okay, this guy right here, same thing. That's where you're getting these numbers, okay? So, FYI, they're not going to ask you, you're not going to, so I have students say, Ms. Flick, I would never use combinatorics. This seems like lots of work for something I can do a lot faster with Pascal's triangle. Good, I agree. But if they were to ask you for like, they give you some term a plus b to the power of, let's do 17. And they want the, find the, let's do the 12th term. Well, I don't want to have to go to Pascal's triangle and go to the 18th row, right? You're like, oh, that's kind of a pain in the butt. Just to figure out the one term in the whole thing. So what I'm going to show you how to do is use combinatorics to pick one term out, okay? So I want you to notice the pattern. Are you ready? So this guy right here was the 3rd term. This has a 2 here. This is a 4th term. This has a 3 there. This is the 5th term. This has a 4 there. So whatever term number you want, you go, okay, well, I know this is going to be 17. Your R value, so your term number is always going to be 1 more than whatever your R value is. So your term number is always R plus 1. So if I tell you I want the 12th term, right, then this guy is going to be a, you guessed it, 11. Notice this, right? 5th term, your R value is 4. 7th term, your R value is 6. So you get the idea, right? So this would actually give you the coefficient of the 12th term in a plus b to the power of 7. Well, there's more to it, Miss Flick. I know I found this would just give me the coefficient. I have to have the other stuff. So let's put this over here. Term number is always equal to n plus 1, right? Or you can write n is always your term number minus 1. I don't know which one would make sense more to your brain, so we'll have both of those. Good thing to put in your notes. Okay, now I need my A, right? And I need my B, right? So you go, okay, it's going to be A to the power of something and B to the power of something. Okay, well, let's look at the pattern. Are you ready? Well, remember, this number right here, notice this R value matches the degree on your 2nd term. Your 4 here matches your 4 here. Your 5 here matches your 5 here. Your 2 here matches your 2 here. So this guy right here, right, your 2nd term was B, right? Your second term was B. So I'm going to match it. These two always have to match unless something's been multiplied out, but we'll talk about that when I see you later. A, your A value, how do I know what this degree is? Ah, you guessed it. These have to add up to how much? 17, remember? 6, 6, 6, 5 plus 1, 6, 5 plus 1. They always add up to what the degree is, so I know 100% that this has to be a 6. So I would either let you use a calculator to get this answer, or you would just set up the answer like that, and that's what the answer choice would look like. That's it. That's all she wrote. Now, the only time it's going to get a little bit funky is they're going to change what A and B are. So instead of A just being A and B being B, what are they going to do? Oh, they're going to do this. Are we ready? They're going to say, hey, let's have 2x minus 5y squared raised to the power of like 18, right, or like 23, and they want the, right, find the 9th term. So you go, okay, I've got 3 things. I've got my combinatoric, so I know this is going to be 23, whatever this degree on the outside is. 9th term, so this is going to be a, you guessed it, 8. My A value is no longer A, it's 2x. And my B value is going to be all of this, including the negative. So this is going to be negative 5y squared. These have to match. And then this is going to have to be, what plus 8 is 23, right? What is that? It's going to be, you guessed it, 15. And then, if I was real mean, I'd say, okay, take out that calculator, actually raise those degrees, find this, and multiply all those numbers together. Otherwise, you're going to kind of leave it like this. So if they want you to actually get an answer like this, they're not going to make these so ugly, right? They'll be like, okay, we'll do x and then minus y squared, right? To the power of 23. Or to the power of, we'll do like a 2 here, to the power of 5. So now you have a choice, and they tell you, or let's do this one. They give you to the power of 9, and they say they want the 5th term. Again, you can use binomial theorem, or no, they'll say, give the term, give what term has a y. We'll do that one in the next video. This one's getting kind of long. Okay, so that kind of lets you know how you can use that. I'll do another one in the next one. See you guys later.